Have you ever sat perfectly still and felt like your thoughts slow down, like the world stretches out for half a second longer? That strange, drifting clarity often comes with a very specific brain state: theta. Stick with me, because what happens in your brain during theta meditation is weirder and more beautiful than you might think. Theta is a rhythm. In EEG terms, it's roughly 4 to 8 cycles per second. But calling it a rhythm makes it sound musical and bland. In reality, theta is like a conductor, quietly coordinating entire orchestras inside your skull. It shows up when you're drowsy, on the border of sleep, when you're deeply focused, and yes, during certain kinds of meditation. Now here's where it gets interesting. Different brain regions don't just turn on and off during theta. They talk to each other in timed bursts. That timing does real work: memory consolidation, emotional processing, even sudden creative insights. First, the anatomy. The hippocampus is the poster child for theta. Animal studies and classic work by people like Buzaki show hippocampal theta tightly linked to navigation and memory encoding. But theta isn't only in the hippocampus. There's frontal midline theta, a different flavor, that pops up in the prefrontal cortex during focused attention and meditation. The medial septum acts like a pacemaker for hippocampal theta, sending rhythmic input that helps synchronize networks. The thalamus and cortical networks join the party too, forming a thalamocortical loop that amplifies and routes theta activity. So what does that synchronized chatter actually do? Think of theta as a timing signal. Neural spikes arriving at the right phase of a theta wave are more likely to trigger long-term potentiation, LTP, the cellular basis of learning. In plain language, theta creates windows of heightened plasticity. It's why you'll hear researchers say theta is ideal for memory encoding and consolidation. Animal experiments showed that delivering stimulation at theta frequency is far more effective at inducing LTP than random stimulation. In humans, EEG studies have linked stronger theta power and theta synchrony to better memory performance. Klimesh and others have made this clear over decades. Theta relates to memory and cognitive control. And there's another layer, literally. Theta often nests faster rhythms. Gamma oscillations ride on top of theta cycles in a choreography called theta-gamma coupling. That's thought to be how the brain chunks information into discrete packets. Imagine slicing experience into bite-sized moments for storage and retrieval. This mechanism is central to theories of working memory and episodic binding. During some meditative states, people report vivid imagery, insights, and the kind of integrative thinking that might reflect enhanced theta-gamma coordination. Now let's talk chemistry. What fuels and shapes these rhythms? Acetylcholine plays a starring role. Cholinergic neurons from the medial septum modulate hippocampal theta. More acetylcholine pushes the system towards sustained theta. GABAergic interneurons create the inhibitory scaffolding that sculpts rhythmic firing. Without GABA, oscillations would fall apart. Dopamine and serotonin modulate the overall mood and salience, tuning how rewarding or meaningful a theta phase signal feels. Norepinephrine, the brain's arousal dial, tends to drop during deep, focused meditation, which helps shift the system away from hypervigilant beta and towards slower rhythms like theta. And cortisol, the stress hormone, often decreases with regular meditation practice, which indirectly supports a neural environment conducive to plasticity and calm. What does the empirical evidence say? Multiple peer-reviewed EEG and neuroimaging studies show consistent patterns. Classic EEG work found increased frontal midline theta during focused attention meditation in experienced practitioners. Reviews of meditation, EEG data report elevated theta and alpha bands across various traditions, albeit with differences depending on style. Focused attention tends to boost frontal theta. Open monitoring alters alpha and gamma in distinct ways. Functional MRI studies show coordinated activity between hippocampus, medial prefrontal cortex, and posterior cingulate during restful, inward-focused states, regions associated with memory and the default mode network. Magnetic resonance spectroscopy studies, a newer and trickier method, have reported shifts in neurotransmitter markers, like GABA, after mindfulness interventions, suggesting real neurochemical change, though the literature is still young and sometimes inconsistent. Let me pause on something important. Not all theta is created equal. The theta you get when you're about to fall asleep isn't identical to the theta of laser-focused meditation or the theta associated with creative insight. Location matters. Phase matters. The pattern of connectivity matters. That's why skilled meditators often show stronger, more coherent theta in frontal midline areas compared with novices. In my experience working with and reading about long-term practitioners, the subjective quality of theta, a sense of effortless attention, emotional regulation, and sometimes bliss, is tightly linked to this coordinated, phase-locked activity. So how might this translate into real-world benefits? The mechanisms we've talked about suggest several plausible outcomes. Enhanced memory consolidation and learning, because theta times plasticity. Better emotional regulation, because theta coordinates prefrontal control over limbic regions. Increased creative insight, perhaps from novel crosstalk enabled by theta-gamma coupling. Reduced stress and improved mood via shifts in neuromodulators and lower cortisol. And there is empirical support for many of these claims. Randomized trials and longitudinal studies show mindfulness and meditation practices can improve attention, reduce anxiety, and sometimes boost memory performance. But here's the caveat. Effect sizes vary, and individual differences are huge. Genetics, baseline stress, sleep, and practice quality all shape outcomes. You might be wondering, can you intentionally induce theta? Short answer, yes, to some extent. Deep, focused breathing practices, body scan, and certain forms of mantra or breath-based meditation reliably increase frontal midline theta in EEG studies. Hypnagogic or shamanic techniques can push you toward hippocampal theta states, but those are less controlled and riskier if you're seeking therapeutic outcomes. There's also growing work on non-invasive brain stimulation, theta burst transcranial magnetic stimulation, to mimic theta patterns and boost plasticity. The technology is promising, but it's still early days. So what should you take away? Theta meditation isn't mysticism hiding from science. It's a measurable brain state with clear mechanisms, rhythmic coordination via hippocampal and frontal networks, timing windows that favor plasticity, and neurochemical modulation that shapes arousal and mood. Peer-reviewed studies back these claims, though the field still needs larger and better controlled trials and more multimodal work linking EEG, neurochemistry, and behavior. If you want a practical nudge, try a short, focused attention session. Sit, breathe slowly, pick a single anchor, your breath, a mantra, the feeling at the nostrils, and gently bring attention back whenever it wanders. Aim for 10 to 20 minutes. Don't chase theta. Let it emerge. If you practice consistently, you may start noticing that slow, spacious clarity I described. And remember, science is catching up. Every study peels back another layer of how these rhythms shape who we are. If this fascinated you, hit like, subscribe, and tell me in the comments, what did you notice the first time you fell into that drifting, almost dreamlike focus? Share your experience. I read them all. Thanks for listening. And keep an ear out for your brain's next quiet rhythm.